Yeah, I went and checked on my C++ students across the hall that were asking for help before class, and they gave up. Cowards. I texted them. I'm seeing what maybe they stopped for food or something. I'll check on them in the next break. Okay, so that was drill 9. The next one is what, drill 10? For us, which was strong password detection. Sound right? Okay. So this deals with regular expressions. If you had to tell me based on your reading, what is a regular expression? What would you tell me? What's the point of that?
It's a tool that helps manipulate strings or find something within strings.
Okay, so it's, yeah, pattern matching within a string, right? That's what regular expressions are. So now, if I were to hold this up, what is this? Phone, okay. If I was to hold this up, what is this? Okay, how did you know that? How did you know this was a cup and that this was a phone? If I was to hold up an apple, would you know it was an apple? How? How were you able to tell these two apart? They're both objects, right? They're both things. How did you know this was a phone and this was a cup? You just did. Human beings are so good at solving problems, we have trouble articulating how we solve them, don't we? All right, so regular expressions are an attempt at giving a human the ability to describe patterns they may see in strings so they can easily identify those patterns later. Okay? Regular expressions are really powerful. The things that, we're only using them for just a little bit of a tip of the iceberg, but, so things you might do with a regular expression is determine if a string contains a match. We might also get a collection of first/all matches. We might also use this to substitute a match within a string. Substitute. All right, like we'll do on the one after this. All right, so that's what a regular expression is. If I were to ask you to list all the properties of this thing that allowed you to glance at it, barely able to, you just looked at that's a cup, right? You didn't have to really put your brain into overdrive to determine this was a cup, right? You just knew. But when I held this up, you said that's a phone. Couldn't I have held up something that was like basically the exact same shape as this? That wasn't a phone, and you maybe would have even gotten that right. You just kind of knew, even in context, that, okay, well, he's sitting up there, he usually carries a phone, that's probably his phone. Right? So human beings, we're just doing some incredibly complex things. Regular expressions are allowing us to just express tiny little patterns in things like being able to determine whether something is an email address or something like that. All right, so for this particular one, was this chapter 7? Yeah, they have a bunch of examples in here that they take you through. But if we go down to, where's the assignment for that? Strong password. All right, so write a function that uses a regular expression to make sure the password string it is passed is strong. And then they say, okay, this is what it means for a password to be a strong password. So it's defined as one that is at least 8 characters long. That's one characteristic of a strong password. It contains both upper and lowercase characters and has at least one digit. Notice it gives you a hint. You may need to test a string against multiple patterns to validate its strengths. So what we can do is we can actually break this down into smaller pieces. I can first check to make sure whatever they gave me was at least 8 characters long. I can do that by just checking the length if I wanted to, or I can use it to check I could use a regular expression to test it. So we're going to use regular expressions since that's fun for us right now. All right, so I'll go in here, and I already put this up on Slack, so I'll just gut this. So you have that code. It's up on Slack. So I'm going to import RE for our regular expressions. That gives me a library that has regular expression stuff built into it. I'm going to write a function strong password detector. And this guy is going to take in a password as a parameter. And what we're going to do is we're going to create a bunch of classifiers or a bunch of regular expression matchers here. And we'll kind of look up top here for some examples. All right, so for example, if I want to create a matcher for phone numbers, I can choose to say, well, a phone number has 3 digits, followed by a dash, followed by 3 digits, followed by a dash, followed by 4 digits, for example. You can do a little shortcut version of that as well, and you can just say, I want a digit with, I want 3 of those digits. Now, if I scroll down a little bit here, and we have our chart that gives us like kind of a cheat sheet for the things we can do with regular expressions. It's down near the bottom. So here's the things we can match. We can match anything that's a numeric digit, 0 to 9. So actually, let's start with that one just for a second, because one of the things that we are looking for a strong password is it has to be at least 8 characters long. It has to have at least 1 lowercase character in it. It has to have at least 1 uppercase character in it. And it has to have at least 1 number in it, right? So could I create has at least 1 number is equal to re.compile, and then say I want \d plus, like that? Will that match any string that has at least 1 decimal in it? The plus sign here says at least 1 of those. So this will find a match for anything I give it that has at least 1 number in it. Correct? Similarly, has at least 1 lower case. Isn't it that? Doesn't that match 1 lowercase? A through Z, at least 1 of them. Has at least 1 uppercase. A through Z plus, doesn't that match at least 1 uppercase letter? All right, go back to our chart here. So a \W says any letter, numeric digit, or underscore character. So we might say those are legal characters in a password. Okay, so I want at least 8 of those. So I could write this a couple different ways. I'm going to write it in the most straightforward way. There's a trick where you can say I want 8 or more. So we're going to say has at least 8 characters, we can't just ask about the length of it, right? Because we really care about it being specific kinds of symbols. You could have a whole bunch of spaces in it and have a length of 8. So I'm looking for something that has a \W, 7 of those, followed by at least one \W. Will that give me something that is 8 or more? Will that match something that's 8 or more? Yep. I can also say that. That will match 8 or more by putting the comma in there. But personally, well, A, I don't use regular expressions that often anymore. So I would say that my skill with using regular expressions is relatively rusty, so I like to be as straightforward as possible. So I think this says it all. 7 word characters followed by at least one more. I think that spells it out. That make sense? All right, so we now have 4 different pattern matchers for matching whether there's a number, a lowercase letter, an uppercase letter, and at least 8 legal characters in our password. And I want to now create matches for those using our password that was passed in. So we can use the search function of this guy. So we compiled our matcher here, but now we can go ahead and use a matcher to search and check for the match. So we'll go ahead and say match 1 means we have that guy dot search password. Now, this will return a value of none if a match was not found. All right, that's what he will do. He will return a value of none if a match was not found. Match 2 is equal to, has one lowercase, password. Match 3 is equal to, has one uppercase. I do, thank you. Match 4 is equal to, has at least 8 characters. All right, so those are my 4 matches. I have tried to pattern match my password 4 different ways here. And I've decided that a strong password means it passes all of those, right? So if match 1 is equal to none, or match 2 is equal to none, or match 3 is equal to none, or match 4 is equal to none. If any of those things are true, if I fail to find a pattern for any of those 4 things, I can print out, you can return false, or I'm just going to print out not a strong password. Else, print out strong password. Make sense? So I have my strong password detector. And we'll try it on the password LOL. That guy should give me a not a strong password. Too short? Not a strong password. But what if I put some uppercase things in there? Is that okay? Still too short? Put some numbers in there. Still too short? We got 1, 2, 3, 4, 5, 6, 7. So that should now be good enough. That's a strong password. And anything bigger will also be a strong password. Make sense? So I created 4 separate patterns to break this thing into tiny steps. One thing we do need to be careful of, and I think the book talks about this, is with regular expressions, especially when you start using them very often. They are very, very, very powerful, and you might kind of get power hungry and get into the situation where you can write these incredibly complex regular expressions that just match these perfect, precise things, and they're almost impossible to read because they're just so complex. I like breaking them into smaller pieces, kind of passing things through a filter. Usually we're not matching. When we're doing pattern matching, we're not doing this thing for a performance reason. Our computers are plenty fast. Okay, I don't care if I have to try to match 4 or 5 or 6 different patterns in order to figure out if something meets a criteria or doesn't meet a criteria. I want to take advantage of the fact that it's easy for me to express what does it mean for a string to have at least 1 decimal in it. That would be difficult. What if I had to write the not difficult, but what if I had to write the equivalent function for def does string have 1 number? This guy takes an S as a parameter. I might have a count starts off at 0. I might go through for C in S for each character in there. Now I want to ask, is this character actually a number? Well, we do have a function called isDigit for strings, so I can say c.isDigit, if I don't have that, I can go and say, well, def is number. This guy takes in a character, and maybe I go ahead and I check. I have a list of all the numbers. So in my numbers, I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, something like that. And maybe I return C in numbers. So this will return true if the character that was passed in was found somewhere inside of these numbers. But even with that in mind, this guy is a character, so I probably want to get the integer version of that, but only if he actually can be an integer. Okay, you see how it's doable? But we gotta write quite a bit of code to just check to see if something's a number. When I can just write a little tiny string like this and say, is there 1 number in there? Is there 5 numbers in there? Is there between 2 and 7 numbers in there? All those are like trivial to do with regular expressions. And we don't have to worry about it. So we're wielding a powerful weapon. That makes sense? Here, I'm going to show you something real quick. I don't think the book covers... I think it's find. Yeah. All right, so if I have a string that's a collection of all my digits, I can try to find a character in that string if it's not found. So an A is not found in this string, is it? This is not a regular expression thing. This is kind of like a quick little search tool. So if it searches for A and this guy returns the first place, it checks bucket 0, bucket 1, bucket 2, bucket 3, and it returns the first place in there where A was found. All right? Or a -1 if it was not found. Make sense? So I can actually see if something was a number by checking against find on the string of all the numbers, and if it gives me a -1, it's not a number. And I can count the number of numbers that were in there. Similarly, notice that the 4, it found that at position 4. 0, 1, 2, 3, 4. The first place it found a 4 in here was at bucket 4. As opposed to if I had put a 4 here at bucket 0, it would have found it at bucket 0. So, nice little tool, ran into Home Depot. Grab that guy. He helps you solve some problems. So that's a nice little thing to have in your back pocket. We'll come back to that here in a little bit. Okay. So, questions on our strong password detector? Not too bad. Okay. How many of you solved it in a similar way to this, where you went through and you broke it into a bunch of individual patterns, or versus tried to create a much more monstrous regular expression? How many of you tried to do it in a, let's call it a small step way like this? Eventually you did it that way? Have you gave up on the monstrosity? Yes, another, maybe a good rule of thumb for programming in general. Don't try to get fancy right off the bat. Maybe never try to get fancy. Solve the problem in a way that makes the most sense to you first. Then you can expand on that later, right? If it makes sense. Otherwise, just make it work. Break it into little steps. Nobody's going to care that you use 4 different patterns. All right, so I'll put this code up on Slack. Okay, so now what we're going to do is we're going to look at an example of the next thing is what? Creating trim. Is it trim? Strip, yeah. Yeah, so in, here, let me just dump this stuff. So if I have a string, and I print out S, then I print out, what is it, S.strip. So first one, notice that S has a bunch of spaces before and after it. So I printed it out. There's S with the spaces before and after it. And when I print it out after strip, it has nothing before and after it. But notice now it's back. So strip will not permanently change the string, but does give you a version of the string that has no leading spaces or trailing spaces. All right. So with that in mind, it actually cuts off more than just spaces. It cuts off anything that's called white space, is what strip does, like \ns, things like that. It'll kick it down a line. But I want to start off by looking at a related example with strings so we can understand the power of regular expressions again. So I'm going to say define, I'm going to call this guy remove vowels. And this guy is going to take a string as a parameter, and we want to return a new string that is the original string with all the vowels removed, A, E, I, O, U, right? All right, so if I go ahead and I create a E, I, O, U, A, E, I, O, U, so a string for this guy called vowels. All right, so there's my vowels string. And now what I'm going to do is I'm going to go through every element of S, and I'm going to check if it's a vowel, I want to get rid of it, right? But strings are what's called immutable. We can't change them. So that means in order to change a string, we have to build up a new string and leave out the things that we don't want. So I'm going to create something called answer here. Maybe start that off as the empty string. We're going to go through, we're going to say for a char in S. So for every character that we have in S, we'll ask if that character is found in here. If it's found in there, we want to skip it. But if it's not found in there, we want to keep it. We can ask this a couple different ways, but I just introduced the find function to you. You can also use the in function. But I'll ask the question, if vowels.find a char, if that guy is equal to a -1, that means this character was not found inside that string called vowels, right? Therefore, a char is not a vowel. So I'll say answer is equal to answer concatenated with a char. Ultimately, I'll return answer. So this guy will take in a string. He will build a brand new string by going through the original string, removing all of the chars from it. Or more accurately, only keeping things that are not vowels. All right, so if I just switch this to hello world, and I print S, then I print remove vowels of S, we see we get the hello world with all the vowels removed for the second one. Make sense? All right. Now, what we can do, though, is we can have a remove vowels, we'll call this 2. There, let's call this remove vowels regex. That'll take a string as a parameter. Okay, and we want to create our matcher for a vowel string. Okay, a matcher for vowels, rather. All right, so we're going to call this guy vowels. And we actually don't even need to do this. I'm just going to write it in multiple lines like this. So what is a regular expression for vowels? This is going to be re.compile. And vowels, we're using a raw string here. That's what that R is for. So if I have a string that looks like \w like that with a normal string in Python, Python's going to treat this, well, it's going to probably yell at me because this backslash is not a character you're allowed to have in a Python string. That's the escape character. So if I wanted to write it this way, I'd have to put double backslashes in front of those. But if I put an R in front of it, that says treat this as a raw string, which means don't do anything special to this guy. Just take what I have in there and make the opening and closing quotes the start of and end of the string. All right, that's what the raw strings are for. It's not required for regular expressions. It'll just make your life easier by having to do less manipulation to clean up your string. All right, so what is a vowel? A vowel is A-E-I-O-U. A-E-I-O-U. That will match a vowel, correct? That's what a vowel is. So now what I can do is I can go ahead and I can return vowels.sub. I'm going to sub nothing for all the things that match this regular expression in S. And I'll return that value. Print remove vowels regex of S. And there's our same hello world. And I could have actually done this by putting my regular expression here. What is it? Is it a third parameter for sub? I don't remember if sub takes 3 parameters if I want to include the regular expression in it.
But without the compile part. So I think sub takes 3 parameters.
Right, instead of compile. So I think I can just do this, right? And it's just re.sub. So I didn't even need my original matcher. I like to create matchers, but you can get it directly. But in any case, I described what a vowel looks like in a regular expression. And then I told that matcher, the pattern matcher, to go ahead and substitute the empty string for any of those vowels found in S. And I removed vowels. It's pretty handy, isn't it? Wouldn't you say that that is better than that? And we even used a shortcut with this using the find power tool. If I didn't have that, I would have had to write another function that went through and tried to determine whether something was a vowel or not. Is it one of these guys? All right. So the sub thing is a pretty powerful tool. Make sense? Okay. So now for the next thing, it was what? Was it from the end of chapter 7? For strip? Oh, was there? Oh. Ninja? Oh, okay. So takes a string, it does the same thing as strip does. If no other arguments are passed other than the string to strip, then white space characters will be removed from the beginning and end of the string. Otherwise, the characters specified in the second argument to the function will be removed from the string. Okay? So we have, let's see, if no other arguments are passed other than the, so we have to have an optional argument in Python. Well, let's write it the first way first. This would have been good enough anyways. So we'll say def strip, and this guy will take in a string that we intend to strip initially, and then what we'll go ahead and do is we're going to create our pattern matcher for white space. Does it say white space or does it say spaces? White space characters will be removed. Do we have a definition of what white space, or do we have a shortcut for a white space? That's really what I'm asking. I mean, we can look up and see what all qualifies as white space. Just put in a collection. What did you use to decide it was white space? Oh, you just did spaces. Okay. And you don't even need to do /s. Or is /s, does it say white space or is /s spaces? Because I don't think, did they talk about /s in here?
No. It is there in the table.
Higher up.
Yeah. It's here.
Any space, tab, or new line character. Oh, yeah, so this is white space. So \s. All right. Otherwise, you could just create a collection of spaces or matches, you know, a space. All right, so we'll have strip. This guy will take in, we'll call this white space. Will be re.compile. We'll take a string here, and there's going to be /s. That is white space, but this will remove any white space in there. We don't want to remove any white space. We want to remove white space at the beginning, and we want to remove white space at the end. So how do I say something that ends in white space? So it's afterwards, right?
Yeah.
So if it ends in white space, get rid of it. Okay? So we'll call this guy white space end. Similarly, white space begin says re.compile, and we say \s caret. Begins with white space. All right. We take our string S here, and we're going to say S. Well, actually, we're probably returning an answer. We're not necessarily changing S. We'll say answer is equal to white space end, doesn't matter which one we do, dot sub, and we'll go ahead and replace white space with the empty string. And then we'll say white space begin sub answer. So we will set answer equal to substituting empty strings for all white space at the end in S. Then we'll set answer equal to substituting all white space at the beginning for what answer currently is, which is the extra white space that we left off from the first one. All right, so we made two passes. We cut it off the end first, then we cut it off the beginning. You could have flip-flopped it if you wanted to. And then we'll go ahead and return answer. And that is a version of strip. We didn't get it off the... This is the spaces at the end. I'm going to replace... Oh, it only replaced one space at the end. I need to replace multiple spaces at the end. So I could say if it ends with a space.
Can't take a plus sign.
It
can take a plus sign.
Yeah, but if I say a plus, so the plus sign would be that, right? Ends with one or more spaces. And this would be begins with one or more spaces. Otherwise, I'm thinking what I can do is just keep calling it over and over again, but there's a shortcut to do it all at once. Where did you put your plus sign?
Before the dollar sign.
Oh, so it's on the S. Okay. So this says match one or more spaces at the end, match one or more spaces at the beginning. And it'll replace all of those spaces, since I said one or more, with the empty string. This would also work if I started it with the star. This says match 0 or more spaces at the beginning and replace that with nothing, even though in this particular case that would actually be inefficient because it always will match 0 or more spaces at the beginning, and so I'm just concatenating on an empty string. All right, so that's a version of strip. And let's see. So for Python, optional parameters. Do I just put a second parameter? Or do I have to mark it as being optional? Or do you not do this part of it?
No, I did it. Without passing the string to the function.
You just say equals none.
Or an empty variable.
Well, but you don't have to pass it. So for instance, if I want to say strip string, something like that is my second parameter there, then what we would do is we would say the default value for strip string is going to be \s plus, like that. Because I think you can give a default value to a string. And then in here, I would say this guy is actually going to be a formatted string. So will this guy, and it will be strip string. Strip string, so whatever that strip string ends up being.
The plus sign. Because we have it in the string.
Oh, thank you. Oh, actually, we'll leave it in the string there. Actually, we won't leave it in the string there because we're matching multiple things. So we'll take it off the string there, but leave it in the thing at the bottom. All right, so that will work for the normal one. But instead, if I say S2 is equal to question marks or something before that, now I can print strip S2, passing it the question mark as my thing I want to strip away. Do that right? S2. All right, so that's not the way to do a temporary.
So I passed an empty variable into the function and just did an if condition.
Right, yeah. There's a better way of doing it. Default param value. I thought I basically wrote that. Oh. I really can't do it. Here, I'll force it to work here. What I'm really saying is I wanted to match a question mark. So now it removed the question marks from it. I kind of had to give it for my, I gave it a default value. So for my strip, I'm saying, okay, you take in a string, and then you also take in an optional second parameter. If you don't give it to me, this is the default value for it, the \s. But if you do give it to me, you have to tell me what you want me to treat as that first character. You can either put the onus on the programmer and say, well, you got to give it to me in a format like this. Or we can build it around build a string around it to make this work, because the default is \s, which is a space. But if I'm doing this, so really I guess I can do it this way. I can say the default is a space, and then inside here, rather than using the slash, I'll just surround that guy with the square brackets saying anything in the collection containing just a space. Now I'll be able to just pass it a question mark. So if I pass in nothing, it'll surround the space with square brackets. If I pass in a question mark, it'll surround the question mark with square brackets. So now this guy still works.
Can you explain again the curly brackets?
Which part?
Around script string up there.
Oh, this guy? Yeah, so I'm using, instead of an R string, I'm using an F string, which is a formatted string. So this is equivalent of me saying, let me just steal this line. It's equivalent to that. Me concatenating in a variable there. This gives you a way of like inserting it as a formatted string. So you can just, by putting the curly braces around it, it says, put the value of the variable called strip string in this place right here. Which is equivalent to what I did here through concatenation.
Was that in the chapter?
It was in an earlier chapter with strings somewhere. I mean, this was just syntactic, sure. You could have done it with just normal concatenation like this. I wouldn't say that for this exact example, one of these is any better or worse than the other one. Where things get better is if you have a whole bunch of stuff you're concatenating into a string. You know, you're building some string, like, my name is Mike. My age is something else, blah, 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 blah. And you're having 10 things you're concatenating in there. You're going to have these plus signs all over the place as you just keep stopping your string, tacking something on, starting a string. Whereas with the F string, you can just embed those variables throughout to get it in there. So convenience. It has nothing to do with regular expressions. It's a string thing. You can use these anywhere strings work. All right, so this would be a version of strip that allows you to have the default strip string being spaces. Otherwise, you can give it whatever you want, including vowels. You can have a string that has a whole bunch of vowels at the beginning of it. Something like that. And then when I call this guy, I'll pass it A-E-I-O-U, A-E-I-O-U. And now it strips the vowels off there. So you can decide what you want your classification to be. All right, questions on that one? Okay. All right, next is Mad Libs thing so we're doing file IO. Okay, and that is chapter 9. Are we on time? Let's do this one, then we'll take another break. All right, so we're going to scroll down here, just get to the project we're actually doing, which is this Mad Libs thing. So we're going to create a Mad Libs program that reads in from a text file and lets the user add their own text anywhere. So this text file is just going to be basically a bucket that holds the string, right? So before we do this, we can actually write the logic for it, where we have something called adjective, noun, adverb, verb appears in the text file. For example, a text file may look like this. The adjective, Panda, walked to noun, and the verb, a nearby noun, was unaffected by these events. Something like this. So I'm going to go ahead and just copy that string for initially. We're going to work with this as strings first. Then we'll write the logic to read that string in from a file. All right. Okay, so it's going to find the occurrences of each one so you can potentially have multiple adjectives, right? I could have adjective in here more than one time. I could have noun in here more than one time. Does that sound accurate to you?
Yep.
Okay. Okay. So I already put this up on Slack, so we'll dump this. I'm going to give myself a starting point for this string. So I'll say S is equal to this. Actually, I don't know if you saw this, but you can actually create strings that multiple line strings with triple double quotes like this. Since this thing went off the screen a little bit, so it makes our life a little easier for just testing here. All right, so I'm going to stop for a second here, and we're going to go back and we're going to revisit regular expressions, because now we might be interested in matching all the occurrences of adjective, noun, verb, those things, right? We might want to match those, and then we might also want to substitute some of them, right? Okay, so let's go back into, what was that, chapter 7? Is our regular expression? All right, so we had a thing called, I think, what was it, find all? Or search all, whatever.
Find the
All right, find all method. So for instance, I could have a string that has multiple phone numbers in it, and we're matching this pattern of what a phone number looks like, okay? And what I can do is I can go ahead and I can say, if I say MO group, this shows me just group at bucket 0. So this is the same thing as group 0. It shows me just that first guy here. If I do search, if I say find all, notice this guy now gives me a list containing all the things it found. That make sense? So I can say I want to find all things that match a certain pattern. In my case here, I'm actually matching multiple patterns. So we'll just create a regular expression out here. So I'm going to say, well, we could actually do it. I'm going to keep it simple and do it one pass at a time. So we're going to go ahead and we're going to say adjective regex is equal to re.compile, and I'm going to search for anything followed by this followed by anything. That's the pattern I care about, right? I care about the word adjective being found somewhere in there. All right. Now, if I go ahead and say, I'll just do a print on it for right now. Print adjective regex find all on S. Let's see, am I using that? Oh, that should work. I got a bug in it. Shouldn't have to have a raw string here. re.compile. I'm looking for, well, raw string's not going to hurt, but nothing in here breaks the rules. I'm looking for something that has 0 or more. Oh, I'm actually just looking for this. So it found 1 adjective in there. I wasn't looking for 0 or more followed by, I would have had to say 0 or more of somethings. Or I didn't put anything in front of it. I said just star, not 0 or more spaces or something like that. I just randomly put an asterisk there. I'm looking for the word adjective somewhere in here. And this will show me a collection of all the places I have adjectives, and I'll just give you an example here. I'll write it again. So notice I get 2 adjectives there. All right. Similarly, if I go back here, I could say I want an adjective, or I want a noun, or I want a verb. Are those the only 3 things?
Yeah.
Okay.
There's adverb in that.
Is allowed.
Yeah.
So there's my collection of finding all those things in the order that it found them. That make sense? Now, go ahead. So it found adjective, then it found noun, then it found verb. Oh, it's actually found noun twice.
Didn't find verb, it found 2 nouns but no verb.
Oh, that's interesting. Did I spell verb funny? Or does this only let me do 2? I think pipe lets me say more than 1. Remember I said, don't try to get too fancy. Well, in fact, actually, let's just do that. We'll deal with adjectives only, because I want to find the collection of all those adjectives. And I'll go ahead and purposely put a second adjective in here just somewhere for our testing. All right, so I'll get a list containing adjective twice here. So that means I want to ask the user for 2 adjectives, for example, because, well, how did you interpret it? That if there's adjective in here twice, would the user get to pick 2 different adjectives they want to enter in? Yep, that's how I'm interpreting it. All right, so I want to now figure out, how do I substitute only the first occurrence of something in my string? Does sub have something built into it that allows me to only substitute the first occurrence of something? Because really, if I ask for, just kind of taking you down the path here, if I say for adjective list, if I say for val in adjective list, and I say input, well, we'll end up putting input. I'll just go ahead and print out val for right now. So we'll see adjective prints out twice. So there's my 2 adjectives. If I want to then go and read something in, and I say, user input is equal to input, enter adjective. And then I want to go ahead and say something like S is equal to and I want to substitute adjective with whatever they enter. So let's just do adjective regex dot sub, and I'm going to go ahead and sub whatever the user entered for well, anything that matches that pattern. So it's going to be in the string S. All right, so I enter something in, I say LOL. It's asking me for both of them. I need to print out S in the end. So let's do it each time through just so we see how S is changing. All right, so I'll type in LOL. Notice now it went and it replaced both occurrences of adjective with LOL. When really, if I'm asking about the first adjective, I only want to replace the first occurrence of adjective. Does that make sense? So, easier problem if we say we're only allowed to have a single adjective, a single noun, a single verb, and a single adverb. But if we're allowing you to have multiple adjectives in there, and we want to handle them in order, we need to be able to only replace the first occurrence of something. So do we have a way with our regular expressions for me to use sub to only substitute the first occurrence of something? How do I accomplish that? Huh?
You put a one flag.
So in sub, where do I put one?
Comma one.
Like that?
I think you need the slash one.
Well, let's find out. So I'll put LOL, and there it just did the first LOL. And then I'll say woot, and it replaced the second one with woot. So this looks accurate to me. All right. So that allows me to go through and find all of the adjectives and things. So, you know, that gives me those pieces, let's say. Now, it would be nice for me to go ahead and be able to identify any of these individual elements. So at the very least, I should be able to do something like this. That or should have worked. Let's just make it for the 3 for a second. And I'm not going to get user input for, just leave it at that for a moment. So there's adjective, noun, adjective, verb, but it matched noun again. I think this must be greedy versus not greedy.
There is another noun in there.
Is there? There's something off the screen here? Oh, there is. And if we throw a adverb in here. So this was adjective, noun, adjective, verb, adjective, noun, adjective. Why is it
Because
the period?
the word verb in it.
What has the word verb in it?
Adverb. I mean, because the
Oh, it captured, well, no, because it found adverb. Oh, you're saying this. now I got the verb. It was matching the first. It was matching the first verb. So I need to be careful if I'm going to use ors to make sure I put them in the right order, that they don't disconnect each other. So now I get the right questions I should be asking, right? So I should be asking for an adjective, a noun, an adjective, a verb, an adverb, and a noun. All right. So instead of saying enter adjective, I'll go ahead and use my format string again here. I'm going to say enter val. Put a little colon space there. So it'll ask me for something. And then I will do my, this actually is no longer adjective. We'll call this a Mad Lib Regex. So I'll say enter a vowel, whatever vowel was. So it's going to be, you know, adjective, noun, adverb, or verb based on what I'm going through for my list. I'll ask for a value. I'll substitute the next thing for that in my Mad Lib Regex, and ultimately I will print out S. Adjective regex is right here, and this guy is called Mad Lib Regex now. All right, so I'll just put stuff in here. So there, it replaced all my parts with the parts. All right, so that's effectively what we want to do, right? All right, but now I want the source of this string to come from something else. So what I'm going to do is I'm going to take all of this stuff here, and the function was supposed to be called, it's 9, right? It reads in a text file, lets the user add their own words anywhere, blah, blah, blah. Prompt the user to replace them. And then it would create a brand new text file, right? Or did you read it as it overwrites the existing text file? I think it should create a new one. So it should be printed to the screen and saved to a file. So let's get it printed to the screen first, then we'll do the file save part. So I'm going to copy all this stuff. And the name of the thing is called Mad Libs. I'll just create a Mad Libs program. All right, so we're going to call this guy def Mad Libify, and this guy will take in a string, and that will Mad Libify that string. And right now we'll just print S on the end of it. All right, and actually, just for the sake of, since we've already tested the rest of it, I'll steal this guy again. We'll just give ourselves the original string. So Mad Libify that guy should give me this, and let's enter in the, so they do silly, I can't spell half those words. Here, we're gonna copy chandelier. Silly chandelier screamed pickup truck. Silly chandelier screamed pickup truck. So the silly panda walked to the chandelier and then screamed. Oh, I have some extra. It's accurate. I just have a really poor cut and paste job going on here. All right, so here we can. We'll hit this again with a little bit better cut and paste job. All right, call that good. All right, so madlibify, if I were to hand this guy a string, he'll ask the right questions and produce for me a repaired string, right? So right now I'm printing that string. Instead, I want to go ahead and return that string. All right, my modified string, because that's ultimately the guy I want to write back out to a file. Okay, so now we got to go do our file stuff. All right, I'm going to go ahead and we're going to create a new, and we're going to call this guy madlib.txt. Let's call it madlibin.txt. All right, and I'll paste my thing into that madlibin.txt. Okay, so now we want to go back and say, how do I read, instead of having s just be equal to this, how do I read that in from the file? All right, so this allows us to work with paths and things like this. So let's go down to reading files. File reading and writing process. All right. So we can, we're going to need our path library thing here. I'm also going to need my regular expression thing here. All right. We're going to go ahead and give myself the path to my file. Oh, that's fine. We'll just prep for this. So we're going to say path. We're going to call this guy output. Is going to be mlout.txt. That's what we're going to write out to. But we're also going to be reading in from something here in a minute. All right, so we're going to give ourselves another path. So we'll call this, we'll say in text is equal to path. And what did we call our, we called it madlibin.txt. All right. And then to read from it, we're going to say s is equal to read underscore text, in text, read underscore text. All right, so that'll read the stuff into S. We'll say something like answer is equal to that. And then we'll say output dot write text, whatever answer gave us. And we should where's it put our stuff? Documents? Well, here, let's open it from Tommy. So here's our ML out, and there's our output file with the stuff in it. All right. So that makes sense for that one. So we solved the problem with strings first, then we just wrote the wrapper for the file I/O around it. Cool? All right, so I'll go ahead and put this up on Slack. And moving on time. So let's take 10 minutes, come back at 8:50, and then we'll take it across the finish line.